Aranak everybody, we continue talking about Ansys, and today we talk about Ansys Workbench Introduction course and the almost last presentation. It's a design exploration tools for researchers, synthesis and optimization. Yep, it's not the end point on the list, but it's the last presentation. Both the last will be without presentation, with real life shown. So, design exploration. Short review about things that we talk in previous videos. We need to create design investigation process schematic on a workbench. We create on a tab which called project schematic. We create it with toolbox which contain a collection called analysis system, component system, custom system, design exploration system. Analysis system, it's an object that's ready to use during different calculation of different tasks: static structural, model, fluid flow, backlink, and so on. When you use one of these tools, use this object, you create object on a schema which look like this. It has name, the same as object. It has some stages, some features that can be found on component system, for example, and during those creation we can also add some parameters. We can add parameters on any stage. If we create parameters on engineering data, on geometry, on model and setup, in most cases it will be input parameters. Some of them can be output, for example, volume and mass of geometry, for example, number of elements and nodes, but in most cases all things that we do, that we say as parameter here, it's the input parameters. And on result we can choose some result, say that we want to see this as a parameter, and it will be output parameters. When we create input or output parameters, object which called parameter set appear on an Ansys Workbench project schematic. And we have one or two arrow that show that we have this arrow, we have input parameters. This arrow shows that we have output parameters. Depending on what parameters do we have or only one arrow, one of this, or both of them. After we create input and output parameters, we can double click on parameter set. It will open a new tab on project schematic. A window on Ansys Workbench window, we see full list of parameters and we see the table, and in this table we can create different number of design points. Design points, it's a variant of your design. It can be differ by geometry parameters, by load parameters, and so on, by mesh parameters, but it's design points, it's investigation point. So you can create as many rows, it's parameters, and as many horizontal stroke, that means investigation point, the design point. And all this design point can be the same or can be differ. If it's the same, you will be calculate a lot of time one task. It's not very interesting and it's not very right, but you can duplicate many times this current design and then change some input parameters, and you will get a result for those collection of input parameters. Also, you need to know that you need some time to obtain here numbers for result, and this time are equal to one calculation time multiplied to number of calculation with some additional time to restart different applications, and it can be very big time depending on time of your analysis and depending on number of analysis. Also, you can check here mark that you want to retain those results. It means that you will receive from calculation not only those two numbers or any number of numbers, any number of results that you set as output, but also you save all calculations, and you can set any design point as current and open it. It's very powerful tool, but you need to understand that you also need a lot of space on your hard disk. If you doesn't have, you will get the error. And also storing these results have some additional time, needs some additional time. So if you uncheck this mark, you will get solution faster. But you sometimes have some problems. You can't visualize those design points. You can check it and so on. If you want to check, you will need to recalculate it. Also, I need to say that all these design assessment tools are design exploration tools are very big, huge and complex. So today we will only show possibilities, but if we need to talk of all tools of design exploration, of optimization, of Six Sigma and so on, we need course, separate course for design exploration with a lot of different video. And those courses can be only after some information about Ansys Mechanical and how to calculate something in right way. And also it must be only after courses about numerical solution, about finite element modeling, about optimization, because in other way we need a lot of things that we need to explain here on a course of design exploration. So today is a short review for understanding that Ansys have some features for design assessment, for optimization and exploring your designs. But we will return to this presentation and this theme much later after some courses. So that's how look our input parameters. We created in Design Modeler. It's not very important because we can create geometric parameters not only in Design Modeler, we can create it in Space Claim, in Discovery. We can import it from original native code. If we have integration with this code, and if you have license, but Design Modeler is also a good tool for creating simple parametrical object or simple parametrical features for investigate and researching some things. Here we have two parameters, vertical and horizontal. Both of them are parametrical. Here we see mark is P letter, and when we click here, we create parameters. In calculation, in analysis, we also can create a lot of different parameters. For example, this load can be as parameter, some meshes preferences, and so on. And any type of result that you will create, you can choose some of them, choose any number and say that this number, for example, here it's maximum result from total deformation from all construction. So this is also parameters that we need to explore. Okay. Additional parameters, it's maximum from equivalent stress. If you don't need on wall construction on all bodies, you can select some bodies, select some faces, select some points or even nodes for those results. You can select any kind of result and even create your own result for this analysis. But for working with input parameters on a geometry, for working with input parameters on Ansys mechanical, on mesh, on material, on boundary condition, and for work with parameters on result, we need some information which we will talk about on other courses. Some of them about on the courses of CAD of Ansys Workbench, and some of them on a course of Ansys Mechanical. So here it is, our design assessment. It's a tab for exploring the result of design, changing design parameters and obtaining solution. Here we have all parameters and we see how change our parameters. It's not very understandable how it looks, but for example, here we have the first parameter and it changed by this way. On a 2 calculation we have 0.1, on second we have 0.2. So additional, more complex and more powerful than design assessment. Design assessment are not present here because, as I said previously, design assessment we run when we double click on parameter set, on simple parameter set. So we can use different assessment tool for design points, design parameters, when we create set of parameters. And for those parameter set we also can do some additional things. One of these is 3D ROM. ROM is a reduced order model. For example, you have a very complex CFD calculation with a lot of cells and so on. And this calculation take, for example, couple hours. But you need to do some system analysis and do some changing of output parameters with input parameters, and do it very quickly. Because, for example, you need to drive this object, and if it's too hot, for example, you need to add more cold water here. For example, if it's not very hot on output, you must change input volume or velocity of cold water for colding this one, because you need to have some range of temperature in the end of this cooler, and you need to drive it. And you can, but if this situation can change every second, and you need a couple hours to solve what kind of velocity you need here for cold water, it's not very good solution. So Ansys create for digital twins a reduced order model, which reduce the model size, which help you to create a lot of different simulation, and collect it to one 3D ROM model, which will be which can be calculated for a second but not an hour. And this is how we create them. We create input parameters, output parameters, some points, number of calculations, number of samples, and so on. We here how it look like. We create with what result we can control it, and we do some calculation, and after that we obtain those ROM model, which we can view in other application. We can change those input parameters and see 3D view and result in a second. And we can apply this one to system analysis and be very happy with this possibility, something like that. But there are one problem. For today, 3D ROM work with limited number of application. Sometimes ago it worked only with Fluent. Now you can use it with Fluent and CFX. But if you need to get something like that with Ansys Mechanical, for example, or Afterdyne, or I don't know, Maxwell, for example, it can be tricky and you can't use them. You can do something analogical in another way, but for my thoughts, Ansys do some mistake, and will be very great solution if Ansys create version of 3D ROM for any type of analysis, not maybe for any, but for most useful type of analysis for different peoples. So, direct optimization. It's an optimization where you have some parameters, you change those parameters, and you change result. And you say that you want to minimize or maximize some result. It can be one parameter, several parameters, it's no matter. And Ansys try to change input parameters and obtain the better solution. It can use a lot of different type of direct optimization. For default, it's genetic algorithms, sorry, not generatic, but genetic algorithms. And you see, we start here and we came from this point to here and minimize our result. But you need to understand that if you create optimization not in the right way, you will do some dumb things and you will get dumb result. For example, here we minimize deformation, but we don't control, for example, mass of construction. So it's not so simple. We need to talk about this. Also, you need to understand that direct optimization use several calculations for obtaining optimum design, and it can be a lot of. For example, for those beams that we show on a previous version, which fix it from one side and have force from other side, it's cantilever beam, and have only two simple parameters, height and horizontal and vertical. Okay, and you see we spent about 20 points to get optimal design, and in the end of optimization we do both parameter maximum. So we change all parameters and okay, we spend 30 calculation for obtain this result. So it's cool things, it's cool tool, but if your calculation are not about seconds but about hours, direct optimization can be very long, can need very long time, about weeks, for example, and sometimes it will have problem because of setup of your task for optimization and task for analysis. Parameters correlation. For example, here on cantilever beam we have vertical and horizontal dimension, and vertical dimension are more important for changing stiffness of beams than horizontal, because horizontal change with linear equation, and vertical with square or cube, I don't remember. So with vertical we can do small changes and obtain much more stiffer result than with big changes on a horizontal. And parameters correlation, it's a tool that creates a lot of small different calculation, and can say that changing of first parameters are very important and very change first parameter, and those diagonal are very dumb things. But also we can say that second parameters, vertical, are more important for changing total deformation and equivalent stress than first parameters. Yep, we know it, but for simple construction, if we have much more difficult construction, complex construction, it can be not so viewable. So what these parameters correlation give to us? It gives to us that we know for this point better to do direct optimization with second parameters. In some other point, for some other cases, it can be different. So we can check correlation of parameters with correlation matrix, with sensitivities, with determination histogram, with determination matrix, and so on. We can do this research, and we know that we doesn't need first parameter for the optimization of construction. Now for those beam, direct optimization are more speed solution than those parameters correlation. But for complex geometry, for complex tasks, parameters correlation are very important. Okay, response surface. We do something like parameters correlation, but with bigger range. We do a lot of different points where we obtain solution, and all these points create some surface in n-dimension space, and this surface for this task look like this one. It's not very it's not very good for understanding, so I show you other picture. So we create those response surface, and after we create those response surface, we also can do some investigation about response, about sensitivity, and so on. And after we create those response surface, we can create a response surface optimization. So we use surface that we take on a previous calculation as surface which already have maximum, minimum points, and we try to find it with different type of interpolation and extrapolations of result. So this is our optimization, and we don't solve those number of points as in direct optimization. We obtain solution from surface, from response surface. So those optimization came much faster with analogical number of points than direct optimization. And we can visualize result in a different way also, and we can get result of optimization. When we do some optimal construction, or we have another construction, we sometimes need to understand that small changes of input parameters or technological parameters, or some scene of exploitation parameters can give unexpected result. small changing of these input parameters can affect work of your construction. So you need to create a robust design that will not be affected in some range of input parameters changing, because these parameters are always changed in exploitation, in technology, in design process. We can obtain different collection of value of these parameters, and all this collection must be robust and good for work. It can be maybe not optimal, but it must work as it need. And for those analysis, we can do Six Sigma analysis. It also based on response surface, and it's something between response surface and sensitivity analysis. So it take small range around our design point about our input parameters. We describe this range. It do a lot of small changes with stochastic regime, and it show how it look like on a result. And after obtaining this one is how input parameters changing, and this histogram it's a result of those calculation, and you can see does it work proper to you or not. And if it works proper, you create optimal construction and you are the best engineer. But it's not very simple to work on the right way with those tools. So we talk that they present in Ansys Workbench. We shall talk about what they give to us as an engineer, as a researcher, as people who do some designs. And we return to this task later. Hope see you on the next video.